Hey guys, had a couple questions about the heating and cooling in my basement that I recently got done finishing, and I figured I'd shoot a quick video in regards to that, give you a quick tour. Real quickly before we get started, I have a separate boiler for the heating, and I have a separate air handler up in the attic that handles the air conditioning for the house. So we're obviously looking at the boiler first. I'll show you the heating section and how I ran all the piping for this and tied it all in. Okay, so I think I'll start the tour on the return side of the system here. 3 circulators. Here's the new one I added for the basement. Those 2 were existing. Come around this side, I'll show you how I tapped in. This T here was capped, similar to how this one is now. I took the cap off, added a nipple, put a new T, capped that, and added the circulator. Alright. Off the top of the circulator, I ran some copper. This is a shutoff for this zone. This is an air purge valve, so just a regular boiler drain to purge the air out of the zone. Runs up. I have an elbow up here that has a 1/4-inch tap on it. I added an automatic air vent to purge the air out of the zone. Alright, so now I have a short piece of copper. Up here is a copper to Pecs elbow. And from here on out, the entire system is Pecs. So it's just stapled to the ceiling. And on the other side of that wall there is the finished part of the basement, and it basically runs to all the baseboards. Alright, now again, this is the return portion of the system. So the water is coming back down this pipe and into the boiler to be heated. One other point I wanted to mention, you have to make sure you use the right type of Pecs for heating. This is called oxygen barrier Pecs. This is different than the piping that you would normally use for domestic water. This has a barrier in it that prevents corrosion inside the boiler. Sometimes they call it heating Pecs. Regardless, they sell it down the plumbing aisle at Home Depot, so ask one of the guys there. They'll point you in the right direction to make sure you get the right type of piping for your project. Now obviously you have to feed the baseboard with water as well, the supply portion, and I'll show you that now. Okay, so if you can imagine this part of the system was existing. So I have 2 check valves for the 2 zones. Alright, the water comes out of the boiler and it either goes to one of the 2 zones that were existing. I cut this copper here, and on the other zone I cut the copper there. And what that allowed me to do was raise this whole section of plumbing off the top of the boiler to give me room to add this T. Alright, so I added the T, added another check valve, some copper here, and what that does is that runs up and that feeds the first baseboard on the system in the basement. And that's really it. I just added the couplers, like I said, to tie back in the existing part of the system, and that completed all the plumbing work on the boiler end of this. Alright? Okay, so let me show you the electrical portion of the install now. These 3 boxes on the wall here are called switching relays. These 2 are existing for the 2 existing zones. This is the new one I installed for the basement. Take the cover off, I'll show you the wiring. 120 volts feeds this, so all I did was I tapped off the existing switch here, and that's connected to these 2 terminals. You then have 120 volts coming out. That's that white piece of Romex here, and that feeds over to the junction box on the circulator and energizes the circulator when there's a call for heat. This should technically be BX. I got to switch this. This is all I had today. I installed it. But it's good practice to install all BX for this, the electric for the heating. Okay, up here is the low voltage portion of the system. This wire comes from the thermostat and is tied into these 2 screws here. And basically all the thermostat does is make or break the connection between these 2 screws. Okay, if the basement calls for heat, it makes the connection between these 2, turns this relay on, which in turn turns the circulator on. Okay, when the basement is satisfied, this connection breaks between these 2 screws, shuts the relay off, which in turn turns the circulator off. The only other connection in this low voltage is these 2 screws here. This is called an end switch. This wire is just connected to the end switch in this zone relay down here. And all that does is it tells the boiler to turn on and off if one of these zones is calling for heat. It'll lock the boiler out and not allow it to come on if all 3 zones are off. Alright, and that's basically it for the electrical portion of the system. Alright, so I'm back out here now on the finished side of the basement. This is the first section of baseboard on the heating run. This is all slant fin baseboard I purchased from Home Depot. You can go on the Slant Fin website and you can enter the dimensions for your rooms, the building material that you use, the insulation. There's a couple other questions, but it'll basically tell you how many linear feet of baseboard you need to install to properly heat the space. Alright? So again, an 8-foot section of slant fin baseboard. You can't see it here, it's hidden behind the desk, but the supply side of that Pecs comes into this, feeds it, and then the Pecs goes back in the wall. I can actually show you that over here. You can see the Pecs down here. That comes out of that baseboard, up the wall here, and basically just wraps around and continues down and feeds the next section of baseboard, which is on this side of the basement. And I took the cover off this so I could show you the connections. So pipe comes down behind this wall, feeds this here, water heats the space through the fins, and then goes back in the wall. So the baseboard itself is copper. Alright, what you got to do, here's another one of those elbows that transitions from Pecs to copper. Right, you can see the Pecs stubbing through the wall here with the clamp, and here's the solder connection to the actual baseboard. Okay, this is probably pretty obvious to all you guys, but just in case this is new to you, you obviously have to solder this connection onto the baseboard before you connect the Pecs, because you'll obviously melt the Pecs if you do it the other way around. Okay, so just get all your baseboard on a sawhorses before you start. Solder all these connections on, let them cool before you go ahead and crimp this on here. On the other side of this wall, I have another Pecs to Pecs elbow because it was kind of hard to flex the Pecs from this up into the wall. So there's another connection behind here. I obviously can't show you that because it's behind the drywall, but that's basically how I get the water through the baseboard and back out through the Pecs to the next section of baseboard on the system. Alright, so I put the cover back on here now. So again, this is an 8-foot section of baseboard. So water comes through it, goes back into the wall, goes into the bathroom, and I have a 4-foot section of baseboard that heats this room. So water comes in, goes through, goes back out, goes up in the ceiling here, down this wall, and feeds this last section of baseboard. This is another 8-foot section out here. Water comes in, goes through. Bring you around here. A lot of stuff down here now, but basically down here next to Jake, the water comes through the baseboard, back into the wall, goes up, goes into the ceiling. And on the other side of this wall here is that room that we're in when we started, the boiler room. And the water goes back, feeds down through the circulator and into the boiler. And that's it. That's how the basement is heated. Alright, let me show you the thermostat. This is just a cheap $20 or $30 model from Home Depot. That's programmable. If you remember that wire that was coming off the top of the switching relay, that feeds over to this 2-conductor wire. There's 2 screws in here that you install those 2 wires to. And that's it. This is what will turn the circulator on and off depending on what you have the temperature set at. Alright, lastly, I just wanted to touch on the placement of the thermostat. You never want to place the thermostat directly over a section of baseboard, because what's going to happen is you're going to get a false reading from the heat coming off that section, and it'll shut the thermostat off before the rest of the basement is satisfied. Alright, this section of baseboard over here is plenty far away where that's not going to happen. You also want to install the thermostat at about the midpoint of the wall, not too high and not too low. And another good idea is you place it at the foot of your stairs coming down from your first floor. And just on a side note there, you can see that I actually got the 15 light French door installed, and that worked out nice and throws some nice light on the stairs. But getting back to this again, the heat's going to want to naturally go up the staircase. So the heat from this side and this side is going to pool in this area, and at that point the thermostat will sense that and shut the zone off before the entire basement gets too hot. And again, plan this out and run your wiring to the correct spot before you install your drywall, because installing the thermostat in the proper location is really critical to the system working correctly. Okay, in terms of the cooling, I have two drops that I installed. One's over here on the TV room side and one's over on the office side. This is two 8-inch pieces of flex duct that come down here from the air handler up in the attic. My cooling system in my home is only one zone, so this is shared with the first and second floor, and I haven't had any problems with that. It ran all last summer during the construction, cooled the basement well. Again, didn't have any issues. The only problem I had with installing these was finding a way to get the ductwork from the attic down here, and I'll show you how I did that now. Up to the first floor here, okay, this coat closet on the first floor of my house is directly above that vent I just showed you in the basement. And what I did was I tucked a piece of 8-inch flex duct from the second floor down and through the floor, and that feeds down to the basement. On the other side of this closet is the pantry closet for the kitchen. I have another piece of 8-inch flex coming down that, and that feeds the drop over on the office side. Okay, I'll bring you up to the second floor now, show you how I got the ductwork through that. I got lucky, I have the linen closet directly above that coat closet. So what I was able to do is, back in this section here, I have first piece of flex duct that's down through the coat closet, and there's another piece back here, and that's the one that feeds down through the pantry closet, and that comes down and through the floor. Alright, so up into the attic we go. I'll show you that next. Alright, so air handler, that closet I believe is right here, and there's the two pieces of ductwork that I ran down through that closet into the basement. So just two takeoff boots off the main trunk, taped them in there and zip tied the insulation back on, and we were good to go. So like I said, I got lucky with those two closets directly above each other. I don't know how I would have gotten the ductwork down there if I didn't have that. But you might not get that lucky in your house. You might have to find a different way of doing it. You can always build a chase in the corner of a room and get it down that way. But you should always try to hunt around for closets. That's the best way of doing it. That about wraps it up. Thanks for watching. You got any other questions, post them down below.